Happy birthday to you. Happy birthday to you. Happy birthday, dear Eli. Happy birthday. I'm not in choir, so I know.
Clearly no one else is.
I definitely not. I'm not even going to pretend to say that I am. Okay. So here we go. Let me unfreeze that screen for you guys, and we're going to start with some notes. So I want you to think about what we've been doing. We have been looking for common what? Yeah, we've been looking for common denominators, right? We've been looking at factors and trying to find common denominators. But when we solve a rational equation, we have two options. We can either use cross multiply. So we can either do cross multiply, which sometimes people call that the butterfly method. I hate that, but that's really what they call it. Or why is that not working? It's like half. There we go. Cross multiply, or we can eliminate the fraction. Okay. So sometimes it's easier to just eliminate the fraction. Sometimes it's easier to cross multiply. So in this first example, example A, we're going to cross multiply. So what does that mean? Well, that means that I'm going to take this 2 times x minus 1, and I'm going to take this 5 times 4x plus 5. It kind of looks like a butterfly, maybe a skinny butterfly. Okay. So does it matter what stuff I put on the right side of the equal sign or what stuff I put on the left? If 7 equals 5, does 5 equal 7? I mean, that's not really true, but if x plus 2 equals 5, does 5 equal x plus 2? So it doesn't matter what side we put where. So I'm just going to start with the 2. And I'm going to write out 2 times x minus 1 equals 5 times 4x plus 5. Okay. Now, how do I solve that? Yeah, I have to do some distributing. 2 times x is 2x. 2 times negative 1 is negative 2. Yeah, I'm just distributing. And then on the other side, 5 times 4x is 20x. And 5 times 5 is, yeah. So now I went from this ugly, hideous rational equation to a linear function. So I'm going to move all the x's on one side, all the constants on the other, and solve, right? So can I subtract 2x from both sides? I'm actually going to subtract it. And then I'm going to also subtract 25 from both sides. Is it okay if I do both of those steps at once? Are you sure? So this goes away. The 2x minus 2x is nothing, right? It's 0. God bless you. Negative 2 and negative 25 give me negative 27 equals, let's see, 20 minus 2 is 18x. So I have negative 27 equals 18x. Now what? Yeah, divide both sides by 18. And I find out, let's see, what does that simplify to? Can divide them both by 9. Negative 27 divided by 9 is negative 3. 18 divided by 9 is 2. So x equals negative 3/2, or we could even write that as negative 1.5. Do we feel good with that one? Okay. What about the next one? If we use the cross multiplication idea, for example B, so I'm going to take this and this. So let's see. I have 2 times 2 minus x equals what? Who can tell me what I'm putting on the other side? Yeah, the quantity of x plus 1 times the quantity of x minus 6. Absolutely perfect. So on the left side, what am I going to do? What operation is this? Yeah, I'm going to distribute on the left. 2 times 2 is 4, and 2 times negative 2 is negative 2x. But on the right side, oh, I have to do your favorite F word, which is FOIL. X times x is perfect. X times negative 6, 1 times x, and 1 times negative 6. Okay, so now what? Okay, so 4 minus 2x equals x squared. Okay, and then what? Think about your warm-up activity. Make it equal to 0. Absolutely. So we have to take everything that's on the left side and move it to the right. So we're going to subtract 4 and add 2x to both sides. And I'm going to line them up under the terms that they match, right? So I'm going to line up my constant, minus 4, under my minus 6. And I'm going to line up my plus 2x below my negative 5x. 4 minus 4 is 0, negative 2, and a positive 2 give me 0. So I have 0 on the left side. And on the right side, I have, x squared minus 3x minus 10. Is that factorable? Can you think of two numbers that you can multiply together to get negative 10? Yeah, that when you add them, you get negative 3. Perfect. Positive 2 and negative 5. So since my leading coefficient is a 1, remember when A is 1, the factors that you choose are the factors that you use. So 0 equals x plus 2 times x minus 5. And so what are my two solutions? Yeah, x equals negative 2 and x equals positive 5. Thoughts on that? Do you guys feel okay with that? So you're solid on cross multiplying? Eliza, you're shaking your head no. You want to vomit? Okay. Okay. So let's look down at this next example. So this next example says, hey, take a look at this equation. And this is where I want you to think about your factors. I want you to think about factors. If we could determine the smallest denominator possible, the least common denominator, and we multiplied every single term by that denominator, it would essentially cancel out the fraction, right? And remember with equations, whatever you multiply by on one side, if you multiply by that on the other, then you've kept the equation balanced, correct? So, I'm going to just do something really fast. So I think that 4x is the same thing as 2 times 2x. Would you agree? Okay. So 2 is a factor of the 4x. So if I were to multiply both sides of this equation by 4x, the 2 would cancel out, right? So our least common denominator is 4x. Because if you would think of this in terms of adding, I would have had to multiply by 2x to make this. Does that make sense? Are you guys understanding how I see that 4x is the least? Okay. So here's what that means. It means that we're going to take this equation, 1/2 minus 9 over 4x equals 3 over 4x. And we're going to multiply the whole equation, both sides, by 4x over 1. Okay. The multiplicative property of equality says that I can do that. As long as whatever I multiply one side by, I multiply the other side by. Okay? So I'm going to cross reduce. 2 will go into itself one time. 2, maybe I won't do that yet. I'm going to wait a second. Let me undo that. Let me distribute first, or at least separate it so you guys can see what's going on. This is such a small space for me to fit all this in. So here's what we really have. We really have 4x times 4x over 1 times 1/2. And then I have minus 4x over 1 times 9 over 4x equals 3 over 4x times 4x over 1. That's really what's happening. When I multiply both sides of the equation by 4x over 1, that's really the math that's taking place right there. Does that make sense? Caleb, do you feel okay with that? All right. So now let's cross reduce because you guys are really good with that. 2 will go into itself one time. 2 will go into 4x 2x times, right? 4x will go into itself one time. 4x will go into itself one time. Those cancel out. 4x will go into itself one time. 4x will go into itself one time. So really what I have is 2x times 1, which is 2x. So look, 2x times 1 is what? 2x. This 4x canceled out and just turned into a 1, right? What's 1 times 9? 9 equals, what do I have over here? 3. So we cancel out the denominators. We get rid of the rationality of our equation. Rational is fraction, right? We get rid of that. I'm going to add 9 to both sides. So 2x equals 12, which means x equals 6. Okay. I know it's a lot. I'm hoping that eventually you guys are going to be able to look at them and just the denominator will pop off the page for you, but it'll take a little practice for sure. So let's look at this next example. So which one of these values for x solves this equation? So let's look first of all at what would be a good denominator for me to multiply it by. And here's what I mean. You want to find the smallest number that is divisible by, it has to be divisible by 6. And it's also divisible by 10. And it's also divisible by 15. So let's talk about how we find that. So the easiest way to do that is to start with your largest number. And let's just find multiples of that. Because 15 is not divisible by 6, is it? And it's also not divisible by what? 10. So let's see, that's 15 times 1. What's 15 times 2? 30, okay. Is 30 divisible by 6? Is 30 divisible by 10? So what could that multiplier that we multiply both sides by be? 30. So we're going to multiply both sides of our equation by 30 over 1. And I'm going to distribute again just so you can see the actual math that's taking place, because I think that's going to help you. So I really have 30 over 1 times x minus 4 over 6 plus 30 over 1 times x minus 2 over 10. And it equals 30 over 1 times 31 over 15. That's actually what's happening when we multiply both sides of the equation by 30. That's really what's taking place. So can we cross reduce? Riley, is there anything that we can cross reduce out of this first? What can I do? So 6 divided by 6 is 1. So I have a 1 in the denominator. What's 30 divided by 6? 5. Okay. What about here? 10 divided by 10 is 1. What's 30 divided by 10? 3. These are doing great. That's supposed to be a 3. Okay. What about here? 15 divided by 15 is 1. 30 divided by 15 is 2. So now we have 5 times x minus 4 plus 3 times x minus 2 equals 2 times 31. I know this is a lot. So we're going to distribute and we're going to solve because it's going to give us a linear equation. So I'm going to kind of move that over here. So let's see. 5 times x is 5x. 5 times negative 4 is negative 20. 3 times x is 3 times negative 2 is, and 2 times 31 is 62. Combined like terms. 5x and positive 3x gives me, Eliza, are you with me? You dropped your pencil. 8x. Negative 2 and negative 6 give me negative 26. All equals 62. What next? Add 26 to both sides. Yeah, for sure. So that gives me 8x equals 88, which means that x equals 11. Whew, that's a lot of work to find out that x equals 11, and our answer is number 4. Okay. So same idea, except now we're going to probably end up with quadratic equations. Okay. So some of them might even be square roots, like, or imaginary numbers, right? Where we have to like factor out some negatives. So the easiest thing to do is think about every time you look at an equation like this, you want to say to yourself, what can I multiply every single term by? When we multiply both sides by the same thing, we're really multiplying every single term. So what can I multiply every single thing by to get rid of the denominators? So let's just look at the constants. I have a 10 and a 5. So we know that 10 is divisible by 10. Does 5 divide 10? Does 5 go into 10 nicely? So the constant that we want to multiply by is 10. Now we have to look at our variable terms because we have a couple of variables in the bottom. What is the largest power of variable term that we have in the denominator? X squared. Yeah. So we have to make sure that we multiply by at least that, right? To get rid of the denominators. So we are multiplying both sides of this by 10x squared over 1. Okay, we are multiplying both sides by 10x squared over 1. And I'm honestly not gonna I'm not gonna show you 10x squared over 1 times 1/10 minus 10x squared over 1 times 1x. I'm not gonna show you that. We're just gonna try and kind of talk through it. So 1/10 times 10x squared. What can I cancel out of the denominator and the numerator? The 10 out of the denominator, and what goes away out of the numerator? What else? Okay, maybe I will write it out. Okay, that's all right. So this becomes 1/10 times 10x squared over 1 minus 1 over x times 10x squared over 1 equals 1 over 5x times 10x squared over 1. minus 2 over x squared times 10x squared over 1. Okay, so let's start again. First term, what can I take out of the numerator and the denominator? A 10. Do you guys see that? So that leaves me with 1 times x squared, which is over 1, which is just x squared. That's why we want that. That's why we're canceling out the denominator. What can I take out of the denominator and the numerator on the next fraction? You can take out an x, and that leaves me with what here? 10x. So I have minus 1 times 10x is just that, 10x, equals next fraction. I have a 5x in the denominator and a 10x squared in the numerator. 5 will go into itself 1 time, and 5 will go into 10 2 times. X will go into itself 1 time, and x will go into x squared with 1x left over. So now that becomes 1 times 2x is 2x. Minus, we have a minus there, x squared cancel out. Do you guys see that? So I'm left with 2 times 10, which is 20. Okay, so what do we need to do now to solve this? Set it equal to 0. So I'm going to subtract 2x from both sides, and I make sure that I line it up under the term that it's getting subtracted from. And I'm going to add 20 to both sides, and I don't have a constant over there, so I'm just going to kind of squeeze it right there. So let's see. That gives me x squared. A negative 10 and a negative 2 give me negative 12x plus 20 equals 0. Is that factorable? Are there two numbers that we can multiply together to get a positive 20? That when we add them, we get negative 12. Negative 2 and negative 10. My leading coefficient, or A, is 1. So when A is 1, the factors that you choose are the factors that you use. X minus 10, x minus 2 equals 0. That means that my solutions are what? X equals 10 and x equals 2. Okay. So 2 things that I want to say to you. Number 1, it's really important that you check your solutions. Okay. It's really important that you check your solutions. But number 2, I want you to think about all of the things that you know you can do with your calculator. Okay. So when you get this to a quadratic, x squared minus 12x plus 20, what is one thing that you could do? If you put it into the y equals and you look at your table, I bet you when x is 10, y is 0, and when x is 2, y is 0, right? So those are things that you could look at. Does that make sense? I'm not going to take the time to plug it into a calculator and check every single answer. I'm going to check some of them, but not on this linear function. Next, let's look at example B. So let's just focus on the constants first. What do I have to multiply both sides by so that I can get rid of the 2 and the 4? What's the smallest number that 2 and 4 both divide? 4, yeah. So I'm going to multiply by the constant 4. What is the largest power in my variable terms? X squared. So I'm going to multiply both sides by 4x squared. If I don't multiply by the x squared, then I won't be able to get rid of those guys right down there. Okay. All right. So let's talk about what this means. This means 4x squared over 1 times 1 over 2 plus 4x squared over 1 times 3 over x minus 4x squared over 1 times 1 over x squared equals 4x squared over 1 times 1 over 4x plus 4x squared over 1 times 1 over 2x squared. It is genuinely my hope that you guys don't have to do that with every single problem. I'm hoping that you are going to get to where you can just cross reduce, okay? So let's see. In the first product, I can get rid of the 2 in the denominator, and my 4x squared becomes a 2x squared. So 2x squared times 1 is just that, 2x squared. Okay. In my second product, I can cancel out an x from the denominator, and that leaves me with a 4x in the numerator. 4x times 3 is 12x. Okay. In the last product on this side, remember that's a minus right there. I can cross off my x squareds. And so I have negative 4 times 1, which is negative 4. Or minus 4 times 1, which is still either or. Okay. Moving across the equal. So in this product, I can cross off my 4x and my 4x squared, which leaves me with just an x. X times 1 is x. And in my last product, the x squareds cancel each other out, and 2 will go into 4 2 times. 2 times 1 is 2. Okay, I know this is long, guys. I know that. Stick with me. So combine like terms and set it equal to 0. Well, we really don't have any like terms to combine, but we can subtract x from both sides and subtract 2. So minus x minus 2, because we want it to be equal to 0. So 2x squared plus 10x minus 6 equals 0. Oh, sorry. Yes, thank you. This is a negative 1. 11. Thank you. I can't find my eraser. Perfect. 11x. Okay, so can we do a times plus chart? Is this factorable? So two numbers that I can multiply together, 2 and negative 6 give me negative 12. Adds to positive 11. My factors are, how about positive 12 and negative 1? Perfect. So we are going to factor this by grouping. 2x squared plus 12x minus 1x minus 6 equals 0. Factor by grouping. The greatest common factor in the first term is 2x. I'm going to divide everything by 2x. When I do that, I have x plus 6. The greatest common factor in the next grouping is negative 1. Yeah, both your terms are negative, and typically when that happens, you really need to take out a negative. So I'm going to take out a negative 1, and that leaves me with negative divided by a negative is a positive x plus 6. Do you have your repeated term? Yep, x plus 6 times 2x minus 1 equals 0. So my factors are x equals negative 6 and x equals, let's see, if 2x minus 1 equals 0, I'm going to add 1 to both sides. So that leaves me with 2x equals 1. Divide both sides by 2. Yes, x equals 1/2. Okay. Your coefficient on your x is always your denominator when you end up solving. Okay. All right. How are we feeling about that? Okay. I don't want to take a potty break yet because then our video will be extra long. So let's just we're almost done. Almost done. So this last set of examples, we have to factor to figure out what the least common denominator is. So we need to factor that middle quadratic to figure out what we're going to multiply both sides by. And then we're probably going to have to check these because we're going to end up with extraneous roots, which means that we're going to end up with solutions that don't work, okay? Because whenever you start multiplying by the square of a number, you take negatives and make them positive, right? And so sometimes you're going to get answers that don't really work when you square things. So let's see, how could I factor that middle term, x squared plus 8x plus 15? Okay, so this becomes x plus 5 times x plus 3. So could we use the factors x plus 5 times x plus 3 as our greatest common factor to multiply both sides by? Could that be the number that we multiply both sides by? Yeah, because you see that that would let the x plus 5 cancel out on the left and the x plus 3 cancel out on the right. So I'm going to leave it in its factored form, and we're going to multiply both sides by x plus 5 times x plus 3. X plus 5 times x plus 3. Okay, so I'm not going to rewrite this one. We're going to just try this one as cross-reducing. Look at your first fraction. What do I have in the denominator and in the numerator that I can cross-reduce? What? X plus 5. Take it out of here, take it out of there. Do you guys see that? So that leaves me with x plus 3 times what? Times x plus 1. Okay. Let's look at this next quotient. What do I have in the numerator and in the denominator that I can cancel out? Can I just cancel everything out? Yeah, so that, do you guys see that this crosses out and this crosses out? So I'm just left with plus 18 equals, now let's go over to the other side and cross off the x plus 3, that leaves me with 9 times x plus 5. So it looks like we have to do what on the left? Foil. You with me, Lamar? We have to foil and distribute. Foil on the left, distribute on the right. Foil on the left, x times x is x squared. 3x plus 1x is 4x. 3 times 1 is 3. Plus 18, don't forget about your plus 18 over there, equals, and we're going to distribute, 9x plus 45. Combine like terms. 3 and 18 is what? So x squared plus 4x plus 21 equals 9x plus 45. I need to set it equal to 0, so I'm going to subtract 9x from both sides, and I'm going to subtract 45 from both sides. So now I have x squared minus 5x minus 24 equals 0. Two numbers that I can multiply together to get a negative 8 and a positive 3. X minus 8 times x plus 3 equals 0. So my two solutions are what? X equals 8 and x equals negative 3. So let's check that, okay? You with me? You're falling asleep? So I'm going to check that, and I'm going to go back up to the front, the very original problem. So if x is 8, here's my check. I'm checking 8. If x is 8, I have 8 plus 1, which is 9, over 8 plus 5, which is 13. You got to be with me. You got to be with me. Plus, let's see, 18 over 8 squared is 64. 8 times 8 is plus another 64 That's okay. Plus 15 equals 9 over 11. Okay, so 9 over 13 plus 18 over 128, 143 equals 9 over 11. So someone do 9 13ths plus 8 over 143. You could do this all on your calculator. I'm just trying to use our brains and see if it equals 9 11ths. And 9 11ths, I think, is like 0.19191919, something like that. What did you get? Oh, you did it in your y equals? Cheating. Okay. What? So in your y equals, we'll come back to you. What did you get?
Like 0.1818.
And is 9 divided by 11 also 0.18181818? Yeah, they're the same. Okay. You be quiet about what you just did. We're going to check the other one. What was our other answer? -3. Okay. We're going to check that really fast. We're going to check -3. And then we're going to have David tell us what he did. So let's see. -3 plus 1 is -2 over -3 plus 5 is +2. I think I did that right. Yes. Okay, good. Plus, let's see. 18 over -3 squared is 9. 8 times -3 is -24. Plus 15 equals 9 over what? What in the heck just happened? What happened? Nobody knows? What is this awful stuff right here? Are we allowed to have a 0 in the denominator ever, even on a bright sunny day? Never. So what, that does not equal 0. So what does that mean? It means that this is extraneous. Okay. David, when you input that equation into your calculator and you went to the y equals, what is your output when x is -3? You should get error.
No, it's when x is.
It shouldn't be. It should be error. Oh, that's because you didn't put, you have to put in your original. You always start with the original. You don't plug, so you would have had to put that in, just so you know. So just so you know, when you check, you always have to start with your original. So you would have actually had to put like you would have had to put all of that into your y equals. Okay. And then you would get an error message. You would get an error. Okay. So yeah, -3 is what we call an extraneous solution. It doesn't work because it gives you a 0 in the denominator. It's what we called when we were first doing addition and subtraction, simplifying with addition and subtraction. We called these extraneous solutions, or we called them what? We said that they were excluded values, right? Excluded values. Okay. So let's do this one quickly. I'm going to factor that bottom for you. This becomes x plus 6 and x minus 2. So I'm going to multiply both sides of this by x plus 6 times x minus 2. So what does that give me? Well, first of all, it just gives me a 4 because that first fraction, these cancel out. 4 over 1 plus, and which is just a 4. I should have just not even done that. Plus the x over 6 cancels out. So I'm left with x minus 2 times x minus 1. I have to squeeze over, sorry. Equals, when I multiply this side by the x plus 6 and the x minus 2, those cancel out. So I'm left with 1 times x plus 6. So that gives me 4 plus x times x is x squared. -2x, -1x is -3x. -2 times -1 is a +2 equals x plus 6. Combine like terms. 4 and 2 is what? 6. So when I subtract 6 from both sides, what's going to happen? Well, if 4 and 2 is 6, what's going to happen is I'm going to get a 0. Now I'm going to subtract x from both sides. So I end up with x squared minus 4x equals 0. It's not letting me write because it says that my computer's kind of. So equals 0. That's what I'm missing there. What can I take out here? I can take out an x. And when I do that, I'm left with x minus 4 equals 0. So I just want you to look at your original equation, and I'm going to erase all of this so you can see it. Are there any values, like if x is 0, because those are your two roots are going to be that x equals 0 and x equals positive 4. If I let x equal 0 here, here, or here, am I going to get a 0 in the denominator? No, this is going to give me negative 12, positive 6, negative 2. Okay, so what about the 4? If I let x equal 4, am I going to get a 0 here? Nope. Here? Nope. Here? Nope. So pretty sure that this does not have any extraneous solutions. So this is your answer. Okay, I know that was a lot. I know that those were long notes.